Hey everyone, I'm Omogonix here and welcome to part 22 of my tutorial series where I teach you all how to make a first-person horror game in Godot. So in this part today we're mainly going to be focusing on testing and bug fixing because we're pretty much near the end of making this game now. I know there's a bunch of things that you guys want me to do, like making an inventory system and stuff like that, but that's not really needed for this game, honestly. I might make separate tutorials on how to do that sort of stuff in the future though, not like in a, how to make a horror game series, but just in, separate singular tutorials, like how to make an inventory system or something like that. But yeah, I just don't want to overflood this game more than it needs to be, because this is only like meant to be a small horror game after all, and, feature creep isn't really necessarily a good thing. I mean, it can be sometimes, I've had times when I'm making games and then there'll be certain features I might think of late in development which do end up making the game a bit better. But overall, things like an inventory system aren't really needed for this game, so I don't really see a reason to do it. But I will probably make a singular tutorial on how to do that in the future. So anyways, what I'm going to do now is, as I just said before, I'm going to go test out the game, and together we're going to try spot out some bugs and stuff. Or just, things I might want to change or, add on to. So here we have our intro. So yeah, getting my money, this tutorial game is called. Alright, and then the intro. So the intro's all good. Something which I might do is add a bit more detail to the car. I might add like side mirrors or something, maybe an exhaust pipe coming out. Something else which we could do too. Which I just thought of, is a head bob. Let's actually go ahead and do that quickly. So yeah, that's one thing which is important, guys. Make sure you do test your game, because there could be certain features or like, certain small things or details or, bugs that you might want to fix which you need to spot out. Testing is one of the most important parts of game development. Yes, it can be annoying to, have to test your game, because then it takes away a bit of time from developing it, but also it's actually good. Alright, so I've actually made a tutorial recently on how to do head bobbing in Godot. If you want to watch that tutorial at some point, you totally can, but I am going to be teaching again how to do it here anyway, so you won't really need to. So what I'm going to do is I'm going to add an animation player to my player's head. So I'm just going to add an animation player just like that. And then we're going to create a new animation, and I'm going to call this walk. There we go. So now what I'm going to do is I'm going to grab my camera 3D here. And I'm going to set the position keyframe. So I've shown you guys how to use the animation player. I'm pretty sure you guys know how to use it. You click on the animation player, make an animation, and then you click on whatever node you want to animate. Then you go into its properties, and then you select the keyframe for whatever you want to animate. Now I'm going to create a reset track for this as well, since I want the camera to be positioned how it is here right now. And so what I'm going to do also is I'm actually going to add a mesh to the head, so then we can actually see our head bob properly, because right now we won't really be able to see the head bob too properly because we just got the skybox here. So we're going to add a bit of a mesh here. There we go, a cube, so then we can actually physically see how we're going to be doing our head bob. So for the start of the animation for the position, I am going to move the camera a bit to the left, so I'm going to do negative 0.05, just like that. Then I'm going to set the keyframe, so this is for the start of the animation. First of all, actually, I'm going to change the animation time to 2 seconds, there we go. And then I'm going to go 0.5 seconds into the animation, and then we're going to move this into the center now, so no longer to the left, now the center on the x-axis. And then we're going to move down the Y by negative 0.05, just like that. And then we're going to go to 1 second, and then this time we're going to be moving the X value to the right, so 0.05. And then setting this to 0 here, and then keyframe. Then I'm going to grab this animation keyframe here for the 0.5 seconds. I pressed Control C on it. Then I'm going to go 1.5, and then just go, oh, wait, no, wrong thing. You're meant to then click onto the track again, then go Control V to paste your animation. And then we can just apply the loop here, just by clicking on this, and then when you have this blue icon, that means your animation is looping. So now we have our head bob. So as you can see, this is our head bob, but if you want to smooth it, you can change the yellow symbol here, which is your interpolation mode. You can change this to cubic if you want to, and now it will actually be smoother. So yeah, so as you can see, we now have a bit of a head bob going on. If you want to as well, you can change the speed scale to see what might look better, if you want a faster head bob or a slower head bob. But anyways, once you're done making your animation, now we're going to go into our player script, And I'm actually going to create a variable for our head bob animation. So I'm going to call this head bob anim, and this will equal to, oh, and by the way, you want to do @onReady for this as well, because we're going to be needing to set this on ready, otherwise we'll get an error. So we're going to go get underscore tree. Wait, no, we won't need to do get underscore tree. What am I saying? We just need to do get node, sorry. We just need to do get node and then head animation player, just like that. Alright, so after doing that variable, now what we're going to do is we're going to create a new function, and we're going to call this the head bob. And we're going to be doing a variable in parentheses here called value, and this will be a float variable. You don't have to put float afterwards, but I just want to let myself know it's a float. So what we're going to do here is we're going to go if headbobanim dot speed scale not equal to value, then the headbobanim dot speed scale will equal to value, just like that. And boom, so that there's going to be our headbob function. So now what we're going to do is down here in our physics process function for the player script, so where it says if direction and if is on floor, so basically what we're going to do is, so because if direction means if our player is moving, and I want the head bob anim to only play when the player is actually, standing on the floor, what we're going to do here underneath the if is on floor bit here is we're going to do head bob, and then I'm going to enter in a value of 2.0 since that's the speed of what I want my head bob's animation to be at. And then I'm actually going to do an else bit here, and then we're going to do head bob 0.0. And the reason as to why I'm doing an else bit here is because if our player isn't on the floor but our player is still moving, I want the head bob to no longer be playing, so we're going to set the speed scale of the animation player to 0. And then in the else bit here, we can just do that exact same thing, headbob 0.0, and boom, just like that. Another thing which we'll need to do as well is we'll need to actually do a ready function, so func underscore ready, and then we're going to do headbob anim dot play walk. So then our headbob animation is always playing, and you want to make sure that it's looping too. Alright, so now that we've done that, let's actually go test it out and see how the head bob goes. I forgot to disable the mesh. There we go. So yeah, make sure that you don't forget to disable your cube that's out the front of your player. Alright, so now for the moment of truth. And yep, the head bob looks pretty good. So as you can see now, the head bob is working. So when we move around, you can definitely see that. Oh, and something else which I just realized too is we should probably do some footsteps. I mean, we do have footstep sounds already, but I mean footsteps for like different materials, because I want to do like grass footsteps. I'm gonna continue testing the game for now, just to see if there's anything else that I might need to fix or add. Alright, so we found the key. Oh, we still don't have a key pickup sound. That's something which I need to add. So I guess that's a few things I'm going to be doing in this tutorial. A key pickup sound, different footstep sounds. I think I might want to make a new track for when you actually do end up finding the safe, because then there's like a different change in tension there. I feel like that would be better. Oh yeah, and I need to do more reflection probes in this area too. I forgot. More reflection probes. Alright, so yeah, there are a bunch of things which I actually do want to do now that I've properly tested the game. That's why it's important to test your game, so then you can refresh your memory on certain things. Like, I just remembered just then, like, oh, I didn't finish off adding the reflection probes last time, so that's something which we're actually going to do right now. Alright, now, so what I'm going to do is I'm now going to continue on the reflection probes. So last time we did that room there, now we're going to be doing this room. I think this is probably one of the last rooms which I need to do, I'm pretty sure. We could probably also do one outside as well and see how that looks. And oh wow, now that looks special right there. With I don't know about using box projection for this area. Okay, now that looks more better. Now that we've actually, fixed it up a bit, it actually looks a bit more better now. We might need to move this a tiny bit more over here. I don't know what that black is there being shown. I think it just has to do with the size of the reflection probe. Enable shadows works here pretty well too. So what I'm going to do is I'm actually going to try out a reflection probe on the outside now. Wonder how this will look out here. Also, I'm going to turn off interior since this is an exterior one. I mean, you can sort of see it on the fence the tiniest bit. But other than that, it's not really that much of a difference. So yeah, I believe that's all the reflection probes done that I want to do. Alright, so what I'm going to do now is I'm now going to add a key pickup sound, because I actually forgot to add a key pickup sound for the key. So what I'm going to do with this is I'm actually going to, well, first of all, I'm actually going to put all these reflection probes underneath a node 3D. So then our hierarchy is a bit more neater. There is a bunch more polishing which we need to do with the scripts as well, which I want to try get to at some point. Alright, so now that's out of the way, let's actually add a key pickup sound. So I'm just going to grab like the music audio stream here, duplicate it, and I'm going to call this key pickup. And I am going to change this to the sound effects bus as well. And then we can change the sound to key pickup, or pickup key.mp3 as it's called for me. So my pickup key sound, this is actually from Mushi's Kitchen Reheated. So yeah, so I just grabbed the sound from Mushi's Kitchen Reheated, plopped it in off recording. So now what I'm going to do is I'm going to find my key pickup, my key script code paper. Yeah, I just used the code paper script. Alright, so here I'm actually going to add a variable on ready var pickup sound get underscore tree dot current underscore scene dot get underscore node pickup key, or key pickup as I called it there, sorry. And in my pickup key function I'm going to do pickup sound dot play. So now we have our pickup key sound added into the pickup key function, so now whenever we pick up the key sound should play. Alright, so the next thing which we're going to be doing is we're going to be changing up the player's footstep sounds based on what material they're walking on. So if they're walking on the stone or more wooden material, I'm just going to keep those having the same sorts of sounds. But if they're walking on grass, that's where it's going to change. Alright, so first off what I'm going to do is I'm going to grab my grass here. My grass static body, and it's already called grass, that's good, that's already a good start. So what I recommend you do first is you call your grass, whatever your static body 3D collider is for your grass, just call it grass. Make sure grass is in the name. If it has, you know, grass and numbers or whatever after it, that's fine as well. So what we're going to do is we're going to go to our player script, and we're going to add a new raycast to our player. So I'm just going to add a new raycast, go add child node, raycast 3D. And you just want to plop it at the bottom of your player, and we're going to go set this Y value to maybe -0.2. You want to basically set it to, you know, a lower value than -1. So now I'm going to call this floorcast. There we go. And so now what I'm going to do is I'm going to go into my player script here, and basically what I'm going to do is in my footsteps function we're actually going to add a new variable here. So basically we're just going to be adding in sound array, and we're going to be replacing footstep sounds here with sound array. And the reason as to why is because we're not just going to have one set of footstep sounds now, we're now going to have another sound array, another array of audio streams to be more precise, which are going to be for our grass footstep sounds. So here for now, with our footsteps function, I am just going to put the regular footstep sounds sound array into into the function down here. But then what I'm going to do is I'm going to copy this, paste it, and I'm going to call these grass sounds, just like that. Alright, so now we're going to create a new variable, and we're going to call this floor type, and this will equal to 0 for now. So now down here we'll do if floor type equal to 0, then just the regular footstep sounds will play. However, else if floor type equal to 1, then we can just do our grass sounds. So yeah, basically floor type 0 will just be for the normal footstep sound, so that's if we're walking on like wood, metal, concrete. I'm just going to be using the same footsteps for all those in this game. However, for the grass, we will be creating some new footstep sounds for those. So since I think I already have grass footstep sounds around, I'm actually going to go get those and then drag them into the project right now. If you guys want to, you can either go make your own sounds right now or go find your own as well. So I'll be right back when I get those. Alright, so I'm back and I found some footstep sounds, some grass ones. So there's one for example. These are from my game Bunyip that I made, if you want to go check that out on itch.io. So now that we have our sounds in my grass sounds array, we're going to be adding these sounds now. So I'm going to add 4 new slots because, you know, that's how many sounds I have here. So I'm just going to enter in their names. or you could just drag them in. You could also do that too, just like this. Boop. And boop. There we go. So now we're going to be creating a new script for our floor cast. So click on your floor cast, and we're going to create a new script for it. And I'm going to save this into I'll save this into my player folder, since it is a script a part of the player. Go create. And so now we're going to be doing a physics process function, since I like to do raycasting in the physics process function. And here we're going to do if is underscore colliding var hit equals get collider, so we're basically getting the collider of whatever we're hitting. If grass in hit.name, then what we'll do is get underscore parent, since we're grabbing our player, then we can do floor type equals 1. Or if you want to make sure it only gets set once, we can do if get underscore parent dot floor type not equal to 1. Then we can do get underscore parent dot floor type equals 1. Now, what else you would do if you did have, more footstep sounds that you wanted to use, right? Let's say, for example, you wanted to separate between concrete and metal and stuff. What you'd do then is you'd then do like else if concrete in hit.name, else if metal in hit.name, or whatever names you want to use, and then you'd change the floor type accordingly. But since for me, I'm just going to be having two different sets of footstep sounds here, it's going to be a bit easier for me. So instead of doing that, I can just do else. So basically, we're checking if the static body 3Ds have anything else in the name except grass. So if grass isn't in the hit.name, hit again being the collider of whatever our raycast is hitting, then what we'll do is if get underscore parent dot floor type isn't equal to 0, then it will equal to 0. And to make sure that our footstep sounds don't play when we're not walking on something, what we can do here with our if is colliding, we can do an else out there. We can do an else outside of this. Then we'll just grab this, and then we can set the floor type to something that isn't in our script. So I have floor type 0 and 1 in my player script, but I don't have a 2, so I'm just going to set this to floor type 2, so that our footstep sounds don't actually play. And boom, there we go. So of course, there's many different ways in which you can get different footstep sounds to play for your game. Like I've done it differently than this before in certain other games. It all just depends on the certain game you're making. And sometimes it doesn't hurt to try out new methods of things as well. I always try out new methods for things in my games, even if I've done them before already. But yeah. So of course, now it is time for the moment of truth to see if this actually does work out. So let's actually go test this. I need to actually change the name of this path here, because I didn't realize before, but this path, this thing's called grass too, because I was thinking this was just another bit of grass, but no, it's just a path. So I'm just going to call this path, so then we actually have our regular footstep sounds play for this. Oh, and also another thing which I remembered as well is the key pickup sound. I had a autoplay on this by accident. I'm going to turn that off, so then the key sound doesn't autoplay when we test it out, and there we go. Alright, so we have our regular footstep sounds right now. I'll turn up the volume just so then you guys can hear it more. I won't speak for now, I'll just let you guys hear the footstep sounds. Here, wait, I'll turn down the music as well. There we go. Alright, so as you can hear, everything works out. Now the only thing which I don't like is the speed of the grass footstep sounds. They're a bit slow, but that's my fault. It's because of the sounds which I used from my other game and then imported into here. I should probably speed them up a bit via the pitch scale maybe. But overall, yeah, it works. So whenever we move from the grass to the path, our footstep sounds change back to normal, and vice versa. Alright, so as I mentioned before, the speed of the footstep sounds is, not that good. So what I want to do now is I want to actually show you guys how to vary, the pitch scale of the footstep sounds. Because, yeah, we can have different audio streams to vary how the footstep sounds, but we can also do pitch scaling as well, which can add even more variation. So here's what we're going to do here. So we're going to add two new variables into the function. We're going to call this min range and max range. And we're going to do feet. So we're going to grab our footstep sound, our audio stream player for the footstep sound. Then do pitch scale, pitch underscore scale equals, and then we can do rng.randf underscore range. So we're going to be picking between two random floats, and then we do min range and max range. So the min range and max range. So the min range is like the lowest pitch we can do, and the max range will be the highest pitch we can do. And so yeah, it's just as simple as that. That's how we set the pitch scale there. Now with the footsteps functions down here in our if direction section, what we can do is we can now add our min range and max range to these footstep sounds. So with the regular ones, I'm probably going to do 0.8 and 1.1 for the min and max range, and now for the grass ones, we're probably going to do a bit of a higher pitch so they're faster. So what I'm thinking here is maybe 1.3 to 1.6 perhaps. We could try that and see how that goes. Alrighty, so let's actually go test it out and see if the footstep sound pitch changes well. Alright, yeah, it's gone faster, and yeah, so as you can hear now, the footsteps are actually a bit faster for the grass ones now. Alright, so as you can see here, we've actually got like a ton of errors, and you've probably been wondering like, what are these? Well, it has to do with the compute velocity on our AI. I just realized I need to change the path of this task trigger we get rid of when we load up the checkpoint. There we go. Alright guys, so I figured it out. So I was taking a look at another project of mine because I was having the same issue, and I was just thinking to myself, how did I fix it up in one of my other projects? Because I had the issue one other time and then I fixed it up, but how did I do that? And then I realized, oh wait a second, it's because I checked the process mode to make sure that it was to check if the process mode was actually equal to process mode inherit. So basically, process mode inherit is the default process mode of Godot node. So basically, the process mode determines if a node is currently going to process in your scene or not. So basically what we're going to do is we're going to make sure that the velocity is only being computed if our process mode is equal to process mode inherit. And also we will also make sure to check that a destination is not equal to null as well, just in case. So now when we start up the project again, we shouldn't have any more errors, like at all, when it comes to that. So let's go play, and as you can see, we don't have hundreds of errors popping up. And now when we start the AI, boom, nothing. There is no problem now whatsoever. So yeah, that there is how you fix up the compute velocity problem. Alright, so yeah, we fixed up the we fixed up the AI issue there. So if you guys were having that same sort of thing happen to you as well, that there is how you fix that from happening. I'm sorry it took a while for me to finally get to that, but yeah, we finally fixed it. Alright, so I estimate that we're probably going to get done with this tutorial series in probably about like 2 or more parts now. I'd say about 2 parts, because we're really close to the end. But anyways, for the end of this part, what I'm going to be doing is I'm going to be changing up the music for when we enter the safe room and we see the dead bodies and stuff. So what I'm going to do is I'm going to use the exact same track of what I've got now, but I'm going to turn down the pitch scale to make it like scarier. So that's my plan there. Hopefully my mic's not too loud when it's peaking. I can see it peaking here on OBS. But anyways, let's get back into the engine. Alright, so here we have our triggers. So in my task trigger, which is where we have the enemy being enabled, what I'm going to do is I'm going to grab our music from the scene tree. So for me, I just do get_tree.current_scene.get node and then music, because our music is, right underneath our main scene. So just going to enter in music here. And then I'm going to turn down the pitch scale to something like maybe 0.5 perhaps. See how that sounds. Also, yes, I do know that some of the textures are kind of stretched. Maybe I'll fix that up in the next part as well. Maybe I could add carpet footstep sounds. That'd be nice. Also, some of the sounds I think are a bit loud. I might need to, fix up the audio mixing a bit. And by that, I just mean, turning down certain sounds individually. Also, whenever I test out this game, I always forget to turn on and off the light switches. Like, I always forget that the light switches exist. Alright, so I just got reminded of something else as well, which I actually do want to do before ending this tutorial. It's literally just one more thing. So one thing which I want to do is I want to make sure that our reflection probes actually change whenever we turn on and off the lights, because obviously the scene starts with the lights off, so the reflection probes are going to be dark. But here's the thing, reflection probes, if you only have them set to update once, they're only going to update once. So when you turn on the lights, I'm pretty sure the reflection probes are just going to, reflect what's dark, I'm pretty sure. So here's what we're going to do. So with our, I think it's our light switch. Yeah, our light switch, that's what controls it. What I'm going to do is I'm actually going to add a variable for reflection probe. Now, if you guys aren't using reflection probes, you don't have to do what I'm doing right now. This is the end of the tutorial anyway. You guys can stop watching if you want to. But for anyone that is doing what I'm doing, because you have a reflection probes as well, then this might help you out, of course. So beneath all of this in the toggle light function, I'm going to do await get underscore tree dot create underscore timer, and we're going to create a timer for like maybe 0.05 seconds, just a very small amount of time after everything here gets set. And then what we're going to do is we're going to grab our reflection probe, and we're going to do force update transform. So what I'm going to do now is I'm now going to go to each of the light switches, and I'm going to select the according reflection probes. So reflection probe 9 will be tied to light switch 9, what a coincidence that is. And then light switch 10, this will be connected to reflection probe 10, again, what a coincidence that is. I just realized we don't have a reflection probe 12 in this area, and that this one just cuts off here. See what this looks like if we drag it all the way across. And yeah, it just gives it more of that, yeah, what does it hurt anyway? Let's just do it. There we go. And we'll center this a bit more over here. Yeah. Yeah, you know what? That actually... Yeah, we can work with this, yeah. And I guess reflection probe 11 will be assigned to light switch 12 as well. Alrighty, so I don't know if I've got all the reflection probes connected up, but if there is any that I am missing, I'll connect them in the next part. Also, I think I should probably do something for the lamp as well. I'll do that in the next part as well. But at the moment I'm just sick, you know, I'm coughing more and more as the video goes on. You know, I'll cut out the coughs and stuff, but yeah. Alright, so here's what I'm going to do instead. What I'm going to do is we're going to slightly move the origin offset on its x-axis. We're going to go plus equals 0.01, just the tiniest bit, and we're going to make sure this is based on a toggle as well, so then we don't, you know, move it too out of place. So I'm going to do if not on, then it moves that way, and then else, or we can do else if on just to be safe, and then we can minus the x offset instead, so that there should work. Now I feel embarrassed for even trying that other method. Like I said, I've never actually tried that before, I just wanted to try it out. You know, trial and error, it's a big thing in game development. And there we go. Now we get our intended results. So yeah, I should have just done that to begin with. As you can see, everything's all good, only our player cylinder shows up. So if you do have that happen to you, make sure that your player cylinder, your player capsule, it's a capsule for me, not a cylinder, but make sure that your player capsule is disabled, so then you don't have that happen. But yeah, so as you can see, it now updates the reflection probe. But you know, I don't want the player to be there, of course, but that's because I didn't disable my my player mesh, because as you can see, the capsule is just jumping around freely. Let's go play around with this a bit more. So yeah, now the reflection probes actually update whenever we change the light switch. So yeah, anyways guys, thank you all for watching this tutorial. I really do appreciate it. Oh, I forgot to connect that one up to a thingy-majiggy, to a reflection probe. It's okay, I'll do that in the next part. But anyway, so we did quite a bit in this part, I think. You know, we've just done a lot of bug fixing, finalizing, polishing. You know, we added in some extra features, which I've, you know, just realized, you know, those could be good details to add. Things like a head bob and footstep sounds and stuff. I mean, we already did have footstep sounds, but I mean different footstep sounds. So anyways, see you all next time, and bye-bye.